Number 4, I have to prove that it's bigger than or equal to 0. Now, the way I recognise to do these ones, you go, is I recognise the first part, the x squared minus 4x. So I go x squared minus 4x, and I go through. It's a negative one, as in it's either x minus 1 squared, x minus 2 squared. I don't know which one it is yet. That makes 4x. So if I multiply out x minus 2 to be squared, what I'll get is x squared minus 4x plus 4. It actually matches up pretty closely to what's there. The only difference is, instead of 4, I have 13. So what I can do is I can change it so that it's going to be x squared minus 4x plus 4 plus 9 greater than or equal to 0. Okay, and now that I have that done, I now know to change the first part into x minus 2 squared. X minus 2 to be squared plus 9 is greater than or equal to 0. This is a perfect square. It has to be greater than or equal to 0. It's plus 9. Plus 9 is always greater than or equal to 0. Hence, therefore, both of them are greater than or equal to 0 when added together. Okay, next one, which is number 13. Okay, you go, 13. So, I'm just going to multiply everything out. A plus b by a plus b is the first one. I'm going to multiply this out. I'm going to get minus 2ab plus 2b squared. I'm going to get this is greater than 2b squared is going to occur over here, and 2ab over the other side. Now, I'm also going to multiply out this one here. I'm going to get a squared plus ab plus ab plus b squared minus 2ab plus 2b squared greater than or equal to 2b squared plus 2ab. Now I just have to see what I can cross off and what I'll get away with. Okay, this ab plus the other ab will cancel with that 2ab. This 2b squared will cancel with that other 2b squared. I'm going to bring over this 2ab over the other side. I'm now going to get a squared minus 2ab plus b squared greater than or equal to 0. This is an example of a perfect square. How do I know it's a perfect square? It has a 1, 2, 1 going on. It's the exact same thing as x minus 1 squared. When you square it out, it ends up to be a 1x squared minus 2x plus 1. A 1, 2, 1. The next pattern would be x minus 2 squared, which is 1, 4, 4. The one after that, which is 3, is going to be 1, 6, 9. Does anybody know what the next one is?
1, 10, 25.
1, 10, 25. You're looking for these patterns. Okay? I noticed that this is a 1 minus 2, 1. And if I factorise this, it'll be a minus b squared. That's what it is. It's a 1, 2, 1. A minus b squared. And a minus b squared is always greater than or equal to 0 because it's a perfect square. Right, nothing else to that. Okay, number 14, is it?
Yes.
Okay, I didn't do 14. Where is 14? There, it's there. Now number 14 is actually not too bad either. Okay? Number 14 is bring 4 up the other side. I'm allowed to do that because I'm guaranteed that the number 4 is positive. There's no doubt about it being negative. I'm going to bring the 4ab over the other side. I'm going to get a squared plus minus 4ab plus 4b. 4b squared greater than or equal to 0. Now it's a 1, 4, 4. Okay? So 1, 4, 4 is the same thing as x minus 2 squared, because it's going to be x squared minus 4x plus 4. I don't have x, I have a. I don't have the number 2. I don't have the number 4. I have 4b squared, so it's going to be 2b. Instead of 2, it's going to be minus 2b. So it's going to be a minus 2b squared greater than or equal to 0. This is greater than or equal to 0 because it's a perfect square. Perfect squares are always greater than or equal to 0. How many people got on? Okay guys, 17 part 4. Everybody looking at the boards. Okay, this here, 17 part 4. Okay. What we're going to do is we're going to multiply it out. So P multiplied by Q, PQ. P multiplied by 1 over P. P times 1 over P, anybody? P over P, which is 1. 1 over Q multiplied by Q. 1. 1 over Q multiplied by 1 over P. 1 over PQ. Okay? Alright guys. Shh. Next one. P times Q, PQ. P times 1 over Q. P over Q. That's okay. Next one is 1 over P multiplied by Q. Q over P. And then finally 1 over P by 1 over Q. PQ. Now the trick is here is just get rid of whatever you can. PQs will disappear. The 1 over PQ and the 1 over PQ will disappear. I'm left with a much more simplified version of what I just had. Now, what some of you guys are probably thinking is, look, there's no sign of any squares here.
Could be a 1, 2, 2.
Which there isn't, okay? Now, what we're going to do here is, next thing we're going to do is we're going to find a common denominator for both of them. We can do the 3 lines as we know it, or we can simply just say, look, it's going to be QP. Okay, so if I put a P on the bottom, I have to put a P on the top. If I put a Q on the bottom, I have to put a Q on the top. It changes it into this. Less than P squared plus Q squared all over 2QP. Now it's taken on a very familiar pattern of what we've seen already in this exercise. Cross multiply. Sorry, it's not 2QP, it's just QP, sorry, excuse me. 4 wouldn't work there. Do you know why? How I knew I made a mistake? I would have got a 1, 4, 1. No, that's not it. It has to be a 1, 4, 4 or a 1, 2, 1. So I knew right away that I made a mistake. So 2QP. Next one is less than or equal to P squared plus Q squared. Okay? Bring the 2QP over to your side. 0 is less than P squared minus 2QP plus Q squared. Spin it around if you'd prefer to do it this way. Minus 2QP plus Q squared greater than or equal to 0. Okay. Alright guys. Now all of a sudden it's a 1, 2, 1, isn't it? So it's going to be P minus Q squared greater than or equal to 0. It's a perfect square greater than or equal to 0. They're always going to turn out like that no matter how messy they look at the start. Would you like me to do 17 part 5?
Yes.
Or would you? Same stuff, to be honest.
You just draw that exercise.
Yeah. Okay. And this here is all coming from memory for me. It's all memory of the first chapter when we added cubes and we took away cubes from each other. So right now, when I was in 5th year, I had to go all the way back to the first chapter and re-look at all the formulas because I completely forgot them, okay? So look, what I write down is it's simply just finding the answer. Like it's pure memory. It's not anything I understand. I do understand it when I multiply out, it will turn into the same thing. But what it is this, it's going to be P plus Q into P squared minus PQ plus Q squared. Now, when I'm in a test, okay, and I am unsure about whether this works or not, what I do is I just quickly multiply it out. And remember, the left side has to equal the right side, okay? And if that doesn't happen this way, that means that it's I've obviously gone wrong, okay? Then I multiply Q, I get QP squared, and then I'll get what's that then? Minus PQ squared, and then I get Q times Q cubed, okay? Now, let's see what cancels with what. The P squared Q. Now I'm missing a P squared Q. I am. The first red one should be P squared Q. P squared Q is the same thing as QP squared. They cancel. PQ squared is the same as PQ squared. I'm left with P cubed plus Q cubed. I understand that the formula I just wrote down is the correct one. That's if I'm second guessing myself in the exam and I've momentarily forgotten. The only thing I ever forget is whether or not this is a plus or a minus, this part here. Okay, that's the one I forget. Now, when it comes to my memory, I don't have them both learned off by heart. I have one of them learned off by heart, and then with the other one, I know that this one changes to a minus. Then I know when that one changes to minus, this one changes to a plus. So I just have it learned off that way. Sorry, not that. P squared plus PQ, and that stays the same, plus Q squared. Once again, if I multiply it out, it should turn into P cubed minus Q cubed. Okay, third one, factorize this. P squared Q plus PQ squared. What can we take out of both of them? We can take out 1P and 1Q. Okay, and what we're going to be left with is P plus Q. Finally, the fourth one is going to be P squared Q minus PQ squared. Now, once again, what can we take out of two of these? PQ left in P minus Q. Alright, everything we've done here is the building blocks for part 2. Everything we've done here, we're going to do it again and we're going to use it in part 2. So we're just going to do is just make this a bit, just save it up the top, so to speak, so we can use it whenever we want. Okay, so that's just keep it up there, alright? Now, that's pretty cute. Thanks. Now, next thing, alright, is this here. We're going to get P cubed plus Q cubed greater than or equal to P squared Q plus PQ squared. I'm just going to rehearse off what I did already, because I know that we've only ever dealt in perfect squares, haven't we? So one thing I gotta say, if I said this, is that guaranteed?
No.
No, because if it's a minus number, it will turn back out to be minus. What's minus 2 multiplied by minus 2 multiplied by minus 2? It's minus 8. It's not the same thing as a square. So when we're talking about proving without a shadow of a doubt that something is positive, bigger than 0, we have to get back squares. That's what we're looking to do here. Okay, so let's see what happens. I'm just going to replace this with equation 1. P plus Q bracket P squared minus PQ plus Q squared, close bracket, greater than or equal to, this one is the same as number 3. Now, what's going to happen both sides is, we're multiplying both sides by P plus Q, aren't we? Now, does it say anything about P plus Q being bigger than 0? Why did I need to look for that at this point in time? Why did I have to double check that P and Q are bigger than 0? They're both positive multipliers. Do you understand that? So, sorry, what I'm trying to say here is, alright, I'll show you something now. I was going to simplify this, okay? This is a positive number multiplied by a number we don't know. Okay? So look, positive number multiplied by 3 is bigger than the same positive number multiplied by 2. Are you happy with that? Sure. What happens when we cross off both positive numbers? Do we need to change the sign?
No.
No. Okay. Negative number multiplied by 3, same negative number multiplied by 2. Which side is currently bigger? Minus 15, minus 10. Less than, yeah? If we cross off both minus numbers, what happens now? You gotta change the sign. That's why if I'm crossing off two identical numbers that are being multiplied by both sides, I need to check for sure that it's a positive number for me to do that. Otherwise I am sure whether I should be changing the sign or not. So that's basically why I had to go up to the top, and I knew it was there. It had to be there for me to be able to do this question. Okay? Now that we go back down, we now have P squared minus PQ plus Q squared greater than or equal to PQ. Bring that PQ over to the other side. Now all of a sudden you have what?
Quadratic.
P squared minus 2PQ plus q squared. And you guys have seen this a couple of times already this chapter. What's my next step then?
1, 2, 1.
1, 2, 1, which is going to be a p minus q squared greater than or equal to 0. It's a perfect square. It's always bigger than 0. Okay. 23 part B. P cubed minus q cubed over p squared q minus p q squared. Number 4 it's basically answer of number 2 divided by answer of number 4 from the first part. They're actually the same thing, aren't they? So I write down the answer of number 2, p minus q, p squared plus pq plus q squared, all divided by pq into p minus q greater than or equal to 3. This time it's different. This time p minus q, it doesn't matter if it's positive or negative, and I'm going to tell you why. Do I know if p minus q is positive or negative? I don't know. If q is bigger than p, it's negative. If p is bigger than q, it's positive. But look at this, okay? If I have 3 multiplied by 4 divided by 3, that is basically the number 4, right? 4 is bigger than 2. Everybody's in agreement with that, yeah? I can cross off the 2 3's, no bother. If it's a negative inequality where it's minus 3 multiplied by 4 divided by minus 3, and this is less than, what's it going to be? It's actually still the number 4, isn't it? So it's going to be bigger than 2. You can see it doesn't matter if both of them are positive or both of them are negative. It actually still says 4 is greater than 2.
But if you change the sign to 4?
Yeah, but then I'd have to change the sign on the 4 there to keep it as a fair test. That only the 3 is changed to minus 3. So basically, in a nutshell, I can cross off p minus q and p minus q because they're the same number. I'm not trying to cross multiply them, so everything's cool there. I don't have to worry about that. Now, next thing is p multiplied by q. Is it guaranteed to be positive or is it negative? Lads, p multiplied by q. Positive or negative number? Positive. Okay, so this is what we have at the moment once I cross off the 2 of them. The 3pq is going to cross multiply up. And anybody who can see this is we're just going to get our perfect square out again. Bring the 3pq over the other side and it becomes minus 3pq. So what happens? P squared minus 2pq plus q squared greater than or equal to 0.
P minus q squared.
P minus q squared greater than or equal to 0. It's not too bad. It's a perfect square, it has to be greater than or equal to 0. Let's move on to the more difficult ones. Okay, these ones here. Express a to the power 4 minus b to the power 4 as a product of 3 factors. Okay. I've never seen, I know a cubed minus b cubed. I know a squared minus b squared, but I've never seen a4 minus b4. But there is a way around it. Alright. This a squared plus b squared is a plus b, a minus b. Okay. What I can do with a4 and b4 is I can do this. A to the power 4 equals a squared 2b squared. B to the power 4 equals b squared 2b squared. Now, instead of replacing in the a's position used to be a, now there's going to be a squared. A squared is now in the a's position, so it's going to be a squared plus b squared. Take away a squared minus b squared. The question specifically says 3 factors. How many factors do I have here? 2. Anybody know how to break up one of them? Yeah, you break up a squared minus b squared into a plus b, a minus b. Okay? Now I have 1, 2, 3 factors working out for me, okay? Next thing I'm going to do, from this result, factorize part 2. Okay, so factorizing part 2 is actually going to be quite difficult. So we'll see what happens here. Okay, part 2. Part 2 is going to be a to the power of 5 minus a4b minus ab4 plus b5. What you need to do here, guys, is you need to, what can we take out of the first two?
A4.
A4 leaves A minus B. Okay? What can we take out of the next one? B4. Oh, sorry, plus B4. We'll leave it as plus B4 for a minute. Plus B. Now, you've done these at junior certs. Ideally, it would be absolutely perfect if the two of them were the same. Is there anything I could take out instead? So if I took out minus B4 instead, it then turns into A minus B. Now, do you remember that thing? First number, second bracket, second number, second bracket. So it actually turns into this here. Okay? So it actually will turn into that for you. Now that that's done, what you're going to have to do next is we're going to have to read the next question and figure out what I'm actually being asked. Use the results from 1 and 2 to show that a to the power of 5 by b to the power of 5 is greater than a for b minus a b4. Okay, so what it's looking for me to do is this: a5 plus b5 greater than or equal to a4b plus ab4. What I'd be thinking in a test is, I don't know how to cope with a5 plus b5. I've never seen it. I don't know how to do it. So what I'm going to do is I'm going to bring these ones over the other side just to make it smaller, okay? So what we're going to get here is I'm going to set it up exactly like part 2 of the question above. We're going to have our a5 here. You go. We're going to have our a5 here. I'm going to take the a4b. I'm going to put the a4b right beside it. I'm going to next use my minus ab4 next. I'm going to keep it exactly like the last question, because we've already done the last question. And all of that is greater than 0. Now that we know all this is greater than 0, we need to factorize it. And to be honest, we're just after factorizing it, haven't we? We did it on the last question, so we'll do it again. Take out a4 and you're left with a minus b. Take out minus b4 and you're left with a minus b greater than 0. Now I have a4 a4 minus b4 greater than or equal to a minus b greater than 0. Can anyone in the class tell me why I'm not done yet? This one here, if you read the language of the question, it says where a and b are positive unequal real numbers. Now, the first thing was, if a equaled b, we'd have a problem, because a minus b would then be 0. And you're not allowed to be 0, you have to be bigger than 0. That's why they're not allowed to be equal. That's the first reason why they're not allowed to be equal. Alright, the next thing is, they're positive, they're both positive, which means they're both bigger than 0. Now the problem is the a minus b. We don't know if the a minus b is positive or negative. So therefore I can't say conclusively whether this whole thing is greater than 0 or smaller than 0. Okay, Connor? Okay, so what we need to do next is I need to factorize this the way I did in part 1. And the way it turned out in part 1 was like this. It turned out that a4 minus b4 turned out to be a squared plus b squared into a squared minus b squared. This is all this part here. Then we changed into a squared plus b squared, a plus b, a minus b. That's all the blue part only. Now there's the black part at the end, greater than 0. Now I can rewrite this. I can rewrite it like this. A squared plus b squared, a plus b multiplied by a minus b squared greater than 0. I am dead certain this is bigger than 0. I'm going to tell you why. This is bigger than 0 because, any reason? Both squares. This one's bigger than 0 because A is greater than 0 and B is greater than 0. Where does it say that in the question? It tells me they're positive numbers. And finally, this here is a perfect square. Square, which is greater than 0. Okay, that is a decently tough question. Okay. Last one now. Yeah, sometimes, yeah. Very rarely B in the old stuff. Okay, guys, last one for me. Then you guys are gonna get a lot of practice. Now, A plus B over 2 is less than or equal to the square root of A squared plus B squared over 2. This is the first time I've seen a square root, so I'm going to simplify this down for me. Okay? If I said the number 6 is bigger than the square root of, sorry, I'll do it a different way. Number 6 is smaller than the square root of 49. Are we all in agreement with that?
Yeah.
6 is smaller than? If we square both sides, does it affect the inequality? 36 is less than? Okay, so what I've learned from this is I'm allowed to square both sides. Or am I? Okay, we are, right? So it should be alright. Square both sides. And what do we get? You go. When you square both sides? Okay, we're going to get A plus B squared. What's 2 squared? 4 less than or equal to A squared plus B squared all over 2. Multiply out A squared plus 2AB plus B squared all over 4 less than or equal to A squared plus B squared all over 2. What I'd like to do next is I'd like to change this to a 4. To change it to a 4, I need to multiply the top and bottom by 2. Multiply the top by 2, multiply the bottom by 2, and now all of a sudden they're both over 4. The 4's will cancel off both sides. I'm going to be left with A squared plus 2AB plus B squared less than or equal to 2A squared plus 2B squared. Cross off that one, cross off the 2. Cross off the B squared, cross off the 2. Bring over the 2AB. I'm going to get 0 is less than A squared minus 2AB plus B squared. We've been here before. We've seen this about 10 times already now. Just turn it the opposite way around. Factorize. Perfect square is greater than or equal to 0. Okay, same thing every time. Alright? Now finally, the lengths of a side of a right angled triangle are A, B and C. C is the length of the hypotenuse. Using the result from part 1 or otherwise, show that AB is greater than C root 2 or less than or equal to C root 2. Now, what I have to do here is I have to understand my information I'm given. It's a right angled triangle. Okay, and what's the only rule we know about right angled triangles? Pythagoras. I'm going to do Pythagoras' theorem and see what happens. Shh. Okay. C, A, and B. C squared equals A squared plus B squared. Okay, perfect. Next thing. C is equal to, C is going to be equal to the square root of A squared plus B squared. Yeah? In effect, what I've done is this. Okay? A plus B all over 2 was the first question. It was greater than or equal to A squared plus B squared all over 2. We've done surds before. Surd rule is this. Root 7 over root 2 is the same thing as root 7 divided by root 2. I'm going to do the same thing here. Now, what happens here is I'm going to change the square root sign into, it's going to be square root of A squared plus B squared all over the square root of 2. Okay? Now, we've proven this, didn't we? We proved part 2 already, didn't we? That was the whole thing I did in part 1. I proved that this is true. Part 2 is in part 1. I proved this is true. Yes. Okay. Where A and B are positive real numbers. They have to be positive as well because they're lengths in a triangle. They can't be negative. Okay. And they can't be 0 because it wouldn't be a length. It wouldn't be a triangle if A and B weren't above 0. Okay. Next thing is what I'm going to do next is I'm just going to cross multiply. So I'm going to get A plus B. Now the reason why I'm cross multiplying is the question wants me to get A plus B on its own, and that's what I intend to do. So A plus B is less than or equal to, you looking? 2 multiplied by the square root of A squared plus B squared all over root 2. Now can anybody in class tell me what is 2 divided by root 2? Okay. It's root 2, and I'm going to explain why. The number 2 equals the square root of 2 multiplied by the square root of 2. That's what the square root means. What number, when multiplied by itself, gives you that number? So, for example, if you're really confused by what I just wrote down, most of you guys will tell me root 25 is 5. Okay? Now, therefore, 5 multiplied by 5 is 25. Yeah? So 2 is, and so look, 25 is 5 multiplied by 5. Would you be happy with that?
Yeah.
Alright. 25 is, what is 5? It's root 25. What is this 5? It's root 25. Whatever number you're talking about, it can be any number in the world, is equal to the square root of itself multiplied by the square root of itself. This brings you back up to the number 2. The number 2 is equal to the square root of 2 multiplied by the square root of 2. And all of this is divided by root 2. What's left then? Root 2. So just get up here, rub them out, and what I'm going to be left with is root 2. What is the square root of A squared plus B squared according to Pythagoras' theorem?
C squared.
C. As that was asked to prove, A plus B is smaller than or equal to the root 2C. Or C root 2, same thing. So I proved exactly what I'm asked to do. Okay guys.